Topic 4-6, Factoring Revisited. You can find this referenced in our Holt textbook, Chapter 8, Section 2, and also in 8, Section 6, on page 531 and 566. Now we're going to do some more factoring, and we're still using our boxes. So if you look at the first one, you're putting this into its factored form. You're taking a trinomial and bringing it to its binomial parts. So we've done enough of these. Let's know where we put our x squared in the first box, your last term in the diagonal box here. If you multiply these two together, that's a 12x squared. So you're looking at also getting 12x squared as a product of what we put here and here. You want it, though, to be an add-in of a -7. So you have to think of the factors of 12 that would give you a -7. So you can use the calculator technique that I'd shown you, or you can, let's just list them out. You've got 12 and 1, 2 and 6, 3 and 4. So look closely at these factors to see which one you add together to get a -7. Well, I could use the 3 and the 4, put it in either box, doesn't matter at this point, and you're going to make sure you put your x with it. And knowing that it has to be a -7, the only way to get these two numbers to a -7 is that both of them are negative. So then we're creating our binomials by looking at each of these and seeing what it is that gets us to x squared, an x and an x. This would be a -4 times this x gets me to a -4x. -3 times x gives you a -3x. And then -3 times -4 is +12. So we've created our binomial, two binomials, x minus 4 and x minus 3. Okay, we're trying to do these next ones a little bit mentally. Instead of having to do our box, let's see how many of these we can do without using the box method, but just now that we've done enough of them, thinking of the factors in the first would be x and x. That's going to get you back to x squared. This is understood to be a -1. So if you think of factors of 30 that give you an add-in of a -1, I can list them out, but we're trying to do this mentally. 30 times 1, 5 times 6. Actually, I can get to a -1. You have a 5 and a 6. You want it to be negative, so the 6 would be negative, and the 5 would be positive. So take a minute, do a couple of these, pause it, and try to do these on your own, and then turn it back on and check. But let's just look at each one of these up to 7. We're trying to get it to binomial form, and we're going to factor. Actually, 8 needs a little more work. You're probably going to have to do the box on that one. I'll give you a hint. But we can do this one. Alright, the first would be m and m. Factors of 20 that give you an add-in of 9. Think carefully. And -4 and -5, because two negatives multiplied together are going to give you a +20. B and B, and 7 and 2. Multiplied together, 7 and 2 give you 14. Added 7b and a 2b give you a +9b. So we can do these mentally. 24. We need it to be 5, so 8 and 3. +5, so make this one positive and this one negative. Let's see. 18 would be a 6 and a 3 to give me 9. But you'd have to make both of them negative. This one, if you take the perfect square, since there is no middle term, I'm looking for difference of squares. And in this one, this would be a 2 on both sides. And this has to be the same number as this, The perfect square of 49 is 7. How the middle term goes away is that one of them is a minus and one is a plus. Review difference of squares if you need to for number 7. Now number 8 can't easily be mentally factored, so let's put it into the box method. The first term is going to go here, 2k squared. Last term, negative 12. When you multiply these together, you get a negative 24k squared, so that whatever's multiplied this direction is also going to give us a negative 24k squared. But it would, with these two numbers, you want an add-in of a negative 5. So think a minute and see what's going to give you a multiple of 24 and an add-in of negative 5. And that would be an 8 and a 3. Now, it's carefully where you're going to place the 2. I was working this even just today, and we had to look carefully. If I put a 2 here, you can't multiply 2 by anything to get 3. So you will have to break this into its binomial part by putting the 2 this way, because I can multiply by a 4. Let's see, that had to be a negative 8, remember, because you want the answer to be negative 5. And again, if you need to see that, I'll write it out here. Negative 8k and a positive 3k would give you a negative 5k. So that way this is right. So this is a minus 4, and this would have to be a positive 3. So in its binomial state, you've got k minus 4 and 2k plus 3. A little more practice with the box method and we'll get this. Okay, let's see if we can do this without it flashing. Alright, look at number 9. The area, these are some applicable problems using a factoring technique. You've got trinomials for all these problems, 9, 10, and 11, and you're looking to factor them into rectangles and squares. So you're looking for 2 of its factors. In other words, you're bringing it down to the binomial form. So if you're using the box technique, the first term, last term, this and this is going to make me a product of 18x squared. This and this is a product of 18x squared, but an add-in of negative 7. So think a minute, what's going to give you an add-in of a negative 7? And that would be a negative 9x and a 2x. Because if I combine these two numbers, that's going to give me negative 7. So when I'm breaking it down, again, I'm not going to put the 3 here because there's nothing times 3 that'll give me 2. The 3x will go here, x goes here. This would be a plus 2, and this would be a minus 3. So you have x minus 3 and 3x plus 2. More practice. We're wanting to know what the length of each side. This one actually is going to be your length and your widths are the same, because in this case you're finding the area of a square, so your 2 factored forms will be a perfect square. In other words, this and this will have to have the exact same binomial in it. Again, you're going to put the 4x squared here, a 9 here. Multiplying those together would give you a 36x squared as your products. So going this direction, you also want 36x squared as a product, but you want it to have an add-in of a positive 12. A positive 12, but a product of 36. So 6 and 6 is going to give you 36, but if you add those two together, that'll be a positive 12. So again, this one's not 4 and 1, it's actually 2x and 2x. I know that because I can't put a 4 in either one of these places because nothing times 4 is going to give you 6. But a 3 times 2x would give you a 6x. And a 3 times 2x would give you a 6x. Multiplied 3 and 3 would give you a 9. There's plus signs everywhere. All these are positive. 2x plus 3, 2x plus 3. All right, number 11. The area of a rectangle is represented by this formula, where the width, so they actually give you one of them. So if they're going to give you the width, we can go ahead and put it along here. You could have put it on the top. It doesn't really matter which side you put it. But you do know you're going to have your 14x here and your negative 40 here. So you're having to fill in your spaces here and here to figure out what this would be. So it's actually, I didn't figure out the product of 14 and 40. Let's see what, that one's a big one. Or is it 14? Yeah, 14. So you got, I'm multiplying. 14 times 40 is 560. Whoa, that one's a big one. Maybe I could have factored something out. Let's see. I'm going to have a look at that one again. So 560 divided by... Let's come back to that one. I'll have to look at that one again a little closer. Let's do the bottom one. A rectangle has a length of 4x plus 3 and a width of 5x minus 2. What would be the expression? So in this case, you're wanting the area, so you're looking for the trinomial form. So go ahead and put your 5x minus 2, your 4x plus 3, and let's just multiply this together. This is going to be 20x squared. This times this is 15x. Negative 2 times 4x is negative 8x. And then this would end up being negative 6. Remember, you are combining these together, so when you write this as its final trinomial, your answer is going to be, put it over here, 20x squared, or adding a negative 8x and a positive 15 is going to give you a positive 7x minus 6. The answer is kind of... So this one's a big number. It's 560. So I have to think a minute about what's going to give you a factor of that one. But I'm going to let you go ahead and figure that one out with your teacher. And that concludes section 4-6.